Bismillahirrahmanirrahim. Assalamu alaikum dear students. We are now starting the third lecture for the week 10 for the course of wireless and mobile communication. This lecture is related to wireless networks. We will discuss how a network is established to provide the coverage over a large area. Actually, this is our last week of theory studies, so this will be our last lecture related to this theoretical concepts of this course. So let us start our discussion on wireless networks. So what is wireless network and why do we need that? We understand that cellular telephone system is intended to provide coverage over a large region. Generally, we intend to develop a system in such a way that it covers a specific region with some coverage. So that region is called coverage region. So the wireless network is good if it is able to provide the coverage for that particular region at least. But this is not the only case. Generally, what happens, different coverage regions, they have to be connected as well. For example, if we have a coverage region in the city of Karachi and a coverage region in the city of Lahore, so it may be possible that a user in Karachi may intend to communicate to a user in the in other region like in Lahore. So providing coverage to this entire region requires connecting various different mobile base stations. So generally a single base station is not capable of providing coverage to such a large region. So what we need to do, we need to interconnect different base stations, and in turn we need to interconnect different wireless network so that we can provide a coverage over a large area like a country or a continent. So wireless network, so what is a wireless network? Wireless network is basically an integrated network of base stations which is deployed in order to provide sufficient radio coverage to all mobile users. So how do we interconnect these base stations? How do we create this wireless network in order to provide service to the users in a large region? This network is generally provided by connecting base stations with a central hub which is named as mobile switching center. So what we do, we develop a mobile switching center which connects several base stations together. So in a certain region or in the coverage area, all the base stations, they are connected to that particular mobile switching center, and that mobile switching center provides the connectivity among different users and different base station in that entire area. Even if we consider the simple mobile switching center, it will have a limited coverage because it can only connect a specific number of base stations in that region. So in order to extend the coverage, it is very important to connect MSC with other MSCs in the vicinity, as well as this MSC is connected to the public switch telephone network. We understand that the traditional public switch telephone network, it has been developed and it has been evolved to provide coverage in the large areas. So these MSCs, they are connected to this public switch telephone network in order to extend the coverage and provide the connectivity to all the users in a specific market. So this is an illustration of how do we connect different components of a wireless network. So a base station is generally provides coverage to a smaller region. Another base station would also provide coverage to a smaller region. Similarly, a third base station would also provide coverage to a smaller region, and this coverage is actually wireless. The connection between base station and the mobile equipment is actually a radio link which provides connectivity through a air interface. However, all the base stations, they are connected to a central office which is named as mobile switching center, or sometimes it's called mobile telephone switching office. Generally, this connection is not wireless. This is made by landline or microwave links, or maybe optical fiber links. So this is a fixed network which connects base station to the mobile switching center, and similarly the mobile switching center has connections to the PSTN through the fixed network. So in this way, different base stations, they are interconnected through the mobile switching centers, and different mobile switching centers, they are interconnected by using PSTN. So a user in one region can easily connect to a user in another region by making proper connection through mobile switching center and PSTN. So this entire network accounts for an overall wireless network in order to extend the coverage to all the users or all the subscriber in a specific service area. So how do subscribers communicate to the base station? Actually, the mobile equipment or mobile subscriber, they have to use the radio links to maintain the connectivity with the base station. In order to provide a uniform connectivity, we use a common air interface, CAI. What is common air interface? Common air interface is basically represent a set of protocols. We call them, they are handshake communication protocols, and they define how mobile subscribers would connect to the base station, or how the base station and mobile subscriber, they would use the radio frequencies to make connection in terms of voice and data communication with each other. So this common air interface generally implemented to have a uniform set of protocol in the region, so that all the base stations and the mobile equipment, they can communicate with each other. This common air interface, they also provide a set of control signaling methods, so that different controlling functions are also attained through the same air interface. We must note that because the channel that we are using in the radio links is wireless channel, and we have previously discussed that these channels are random in nature, so we must generate this common air interface in such a way that a sufficient reliability of the communication between the base station and the mobile equipment is achieved. Okay, so a mobile equipment generally connects to the base station by using an air interface. So the link between base station and the mobile equipment is actually wireless, but the link between base station and MSC is a fixed link. We do not need wireless link between the base station and MSC. Generally, these fixed links are in form of wires, or maybe optical fibers, or a microwave links. So at the base station, base station generally removes the signaling data or synchronization data which is required in the air interface portion, which is required for the communication between the mobile. So that synchronization data or signaling data is actually removed. So we call it an air interface portion, which contains the information about the air interface. So we remove the base station removes the air interface portion and transmits the voice traffic, or if it's a data, so it transmits the remaining data traffic to the MSC through that fixed network, and then MSC would connect to whatever location it is required to be connected. So generally each base station has the capability of handling around 50 simultaneous calls, although depending on the design of base station this number can vary, but we can take a typical number of base stations to handle the call as 50 simultaneous calls. But if we look at the MSC, so one MSC has the capability of connecting around 100 of base station in a region. So 100 base station means an MSC is capable of handling around 5,000 calls at a time. So this MSC provides coverage to the PSTN. This MSC provides connectivity to the PSTN and the base station, so that a call can be routed to specific destination wherever we need. So from this number, having a 5,000 calls at one time, we must realize that we must have sufficient capacity between MSC and PSTN. So generally the connection between MSCs and PSTN requires substantial amount of capacity. However, because this connection is not wireless, we know that the wireless spectrum is limited and we cannot make the capacity large. But since the connection between MSC and PSTN is generally a fixed network, so if we need to increase the capacity, what we need to increase the number of connections. So we if we want to increase the capacity, in that case we would be required to deploy more optical fiber cables or more copper wires in order to provide connectivity for more users. Okay, so in this way we can get an overall wireless network, and this network would be capable of connecting subscribers from different regions to the subscriber from another region. One thing that you must note that the term network is actually very diversified type of term, because this is used in variety of different types of voice or data connections. So we have different types of connections available even in wireless systems. We have seen that the current wireless networks, they have evolved from first generation to second, third and fourth generation. So we had networks from first generation, second, third, fourth generations, and each network had its own types of protocols and own types of signaling schemes in order to establish the connection. So there are variety of number of strategies and variety of number of standards that are used in networking, which also depends on the type, whether you are using the network for voice or only for data, like we do in computer networks. So there are certainly a lot lots of standards which are available. There are different standardization organizations as well, which generate standards which standardize the strategies for different networks as well, like IEEE. They have made different standards for different types of networks. However, for this course, for this lecture, actually we will not be going to discuss any specific type of standard. Rather, we will talk about the wireless networks in general. So one of the important part of the wireless network is the MSC or mobile switching center. So let me quickly summarize what are the important functions of this mobile switching center. So first of all, the mobile switching center is responsible for maintaining all mobile related information. So all the data related to a subscriber is generally stored at the MSC. MSCs control the handoff of mobile. So whenever a mobile moves from the coverage region of one base station to another base station, so the controlling MSC decides when to take the handoff. So the handoff function is generally controlled by the MSC. MSC also control whenever handoff is required between one type of MSC to another type of MSC. So MSC also performs all the network management function which are required to properly work for the network to properly work, such as call handling and processing of calls. The billing is generally maintained at the MSC. Fraud detection, whatever fraud happens in the coverage area, that is also monitored by MSC in order to prevent such type of frauds. The MSC connections are very important, because MSC is not only connected to the PSTN, generally the MSC is connected to PSTN, but it is also connected to the other MSCs in the region. And this connection not only have voice and data connection, but also it has signaling channels specific for exchange of location and validation and call signaling information for different users. So by using those signaling channels, the MSCs can exchange the information of different users, like whenever there is need, they update the location of users at the respective MSCs. So let us now quickly compare what is the main difference between this wireless network and the traditional fixed telephone network, or PSTN. So if we compare, generally the fixed telephone network is actually, as the name says, is a fixed network. It remains at a fixed place, and this network is generally established by using cables, for example fiber optic or copper wires, or maybe we use a fixed type of link like a microwave link or a satellite link. However, the wireless network is not a fixed. In wireless network, transmitter and receiver, they have to communicate via electromagnetic radio wave, and both the transmitter and receiver, they may not be fixed at the same place. So they have a flexibility of moving. So there is a mobility associated with the wireless networks. From the network configuration point of view, the fixed network, because they are fixed, their configuration generally do not require changing. So whenever this configuration is virtually static, and whenever we need to change some type of configuration, generally what we need to do, we need to reprogram or adjust the program at the local exchange, so that subscribers information is updated at that particular exchange. However, for the wireless network, the configuration is dynamic. The subscriber information has to be updated on regular basis, because the subscriber have to move from one location to other. So similarly, the routing information has to be updated. So this network configuration is a kind of dynamic, which keeps on changing whenever subscribers they change their location. So whenever we need to make any change at the fixed telephone network, in that case, that change generally requires lots of amount of time, because of the fixed type of services. Say for example, if we need to add number of subscriber in a fixed telephone network, in that case we would be required to lay down the cables, maybe in form of optical fibers or copper cables, in order to increase the overall capacity of the network, or in order to increase the number of users that can be supported by that particular type of network. So whenever we need to make any type of change in a fixed type of network, so that change generally requires lots of effort and lot of time to implement that change. However, wireless network, they are inherently dynamic, and most of the stuff is generally implemented through software programs. So making any change does not take much amount of time, and the changes, they can be incorporated by relatively smaller interval of time. In fixed telephone network, we generally use a telephone central office, which is commonly known as telephone exchange. A telephone exchange can take care of millions of landline telephone connections, depending on the number of connections that has been established in that central office. So a telephone central office has the capability of connecting a large number of calls simultaneously. However, for MSC, because the MSC generally controls the traffic which is coming from a cellular architecture or cellular system. So the cellular system, we know that they have a limited capacity. So the number of connections that can be incorporated in a MSC, they depend on the air traffic capacity. So how much traffic is supported by that particular type of wireless network. For fixed type of network, the data or information that need to be transmitted through the network, that we generally do not require significant amount of overheads for the data. So the data can be directly transmitted from the fixed telephone network. However, for wireless networks, as we know that the geographical location of the mobile users, they keep on changing, and the relative distances and relative nature of the channel between the base station and the mobile equipment, it keeps on changing. So we need to provide lots of overhead data in addition to the voice and actual data that need to be carried through that network. This overhead data provide different types of controlling function. For example, we may be required to have some data that is used for synchronization purposes. So that overhead data it will be used for synchronization. We may be use some overhead data for the error correction and error detection purposes. And stuff like that. So some of the data is basically overhead data, which actually provides some controlling function and do not contribute in the exchange of information between the transmitter, between the base station and the mobile equipment. Generally, the wireless networks, generally the fixed telephone networks, they are kind of fixed because they are based on a fixed type of connectivity, maybe based on optical fiber or a copper wire. So the channel conditions, they are kind of static, they remains almost same. From our point of view, we may consider, in most cases we may consider a linear time invariant channel for the fixed telephone networks, because the channel conditions, they generally remain same. So we do not observe a kind of harsh channel conditions for the case of fixed telephone networks. However, for the wireless networks, the channel conditions, they are changing, they are continuously changing, and we generally observe very harsh and random channel conditions from this type of network. We have previously seen that generally a wireless connectivity or wireless channel is actually a linear time variant channel, which has which keeps on changing with time as well as the time delay. Plus we have different effects which affect different phenomena which actually affect the performance of communication link. For example, the delay spread and the Doppler spread, they generally affect the overall performance of the system. So wireless network has to be designed in such a way that these adverse effects coming from the channel, they are compensated to whatever extent possible. Okay, so let us now quickly discuss what are the limitations, major limitations in the wireless networking. So as a whole, as can be seen from the comparison that I discussed between the fixed type of telephone network and the wireless networking, we can see that the wireless communication system are relatively complex to design because they require an air interface. So this air interface should be capable of providing a telephone grade communication. We should develop an air interface in such a way that it has sufficient quality of service. We know that the channel conditions, they are kind of random in the wireless systems, so the propagation condition, they are quite different from the fixed telephone networks which we observe in the wireless systems. Similarly, the mobility generally affects the overall communication, as the location of any user becomes arbitrary. So we do not have a fixed location for user, so the system need to be designed in such a way that all these randomnesses and all these irregularities, they are incorporated in the system, and we do not see significant amount of degradation in the performance because of these randomnesses. Secondly, in order to provide a coverage in a adequate area, in a large area, we generally required to install large number of base stations. Depending on the coverage area, we would be required to have a number of base station in the region, plus the number of base stations, they are also dependent on the capacity that we want to achieve. We have previously discussed that whenever we want to have higher capacity, generally we go for the smaller cell sites, and if we are going for a smaller cell sites, then that means we would be needing large number of base stations to cover an entire region. So in that case, the number of base station is significantly large. Sometimes this number goes in hundreds in order to provide a coverage to an adequate region. Moreover, having these base stations, we need to establish fixed networks with the MSCs as well. So we no matter how many base stations are there, all base stations have to be connected to some MSC so that we can get an interconnected network that can provide coverage to entire region. And this MSC, they have to provide a connection with the PSTN as well. Generally these MSCs, they not only have the connection to the PSTN, they also have connections to the to other types of MSCs, other MSCs in the region, so that we can have interconnectivity between all types of network in the region. So what are the major problems associated with the wireless networks? First problem that we face in the wireless network is the randomness, inherent randomness available in the channel. So the channel is extremely hostile and random for wireless communications. We know that the users they may request service from any physical location, or they may be traveling at any velocity at any area. This becomes a burden on the wireless network, as the mobile switching center has to force to switch the call to other base stations. So whenever a user moves from one base station to the other coverage region of other base station, in that case the MSC switches the call between the base stations, and this switching has to be done imperceptibly to the user. So whenever a call is switched from one base station to other, the user who is talking on the phone does not feel that there is any switching done at the back end between the users. So this is a delicate task that need to be handled by the MSC so that the user does not disturb from that switching that happens at the back end. The problem with the wireless system is that we have only limited spectrum which is available in the wireless network. We have a major constraint in terms of the specific bandwidth which is allocated in the system. So we can only get a fixed bandwidth, and we want to accommodate as many users as time, and this number of users generally tend to increase over time. So we need to add more users into the system. However, the bandwidth, the total allocated spectrum remains fixed. So in order to add more users, we generally require to incorporate vital techniques to make the overall bandwidth efficient communication. So we have already discussed different techniques previously, like we need to use efficient modulation scheme in order to have optimize the bandwidth use. We may reuse the frequencies so that we can accommodate more users in that limited amount of spectrum. We generally use geographically distributed radio access points so that more users can access the radio resources at different geographical locations. So all this make this wireless network a complicated structure. Secondly, when we intend to increase the number of users, another technique is to reduce the area of the base station. So as the wireless system area reduces, we need to add more base station in the network. So whenever we are adding more base stations, so basically we are adding more burden to the MSC, because MSC has to handle more and more base stations in order to provide connectivity between different users in the network. So this makes the processing at the MSC relatively complex, and MSC required to complete those tasks at very high speed. The geographical location of different users, they are constantly changing in the wireless network, which actually results in overhead of the system, because MSC has to ensure that the connection is maintained whenever the user moves from one place to other. So it's the responsibility of MSC to provide seamless communication even if the user location is changed. So these are some of the problems that are commonly observed in a wireless network. So at the end, let me quickly review different stages of development of wireless network or evolution of this wireless network. We have categorized this evolution of networks as different generation. So we started the first network was actually first generation network, which was intended to support voice calls only, and that was based on analog cellular phones. The first phone, EMS and NMT standards were developed for 1G network. For second generation of phones, not only voice but data was also supported, and the support of data was achieved by using digital technology in the phones. So different standards were used like GSM, TDMA, CDMA in second generation. Similarly, 2.5 generation, which was considered as an enhanced 2G network, which enabled higher, even higher data rates, and the new standards that were developed for data communication was GPRS and EDGE. For third generation phone, we were able to achieve relatively higher data rates that was able to support voice data as well as video signaling. So this enabled the internet surfing and video telephony through these wireless networks. For fourth generation, which is actually enhanced version of third generation network, the interportability protocols were implemented by incorporating the switching in form of packet switching. So from traditional circuit switching systems, the networks were developed on the basis of mobile IPs. At the back end, they had a packet switching network. So this is a simple comparison between different generation of cellular phones. The first generation phones, they were analog. There was no support of SMS. The voice signaling voice switching was based on circuit switching, and data switching was also circuit switching actually, although there was not a significant data support in that network. For 2G network, the major development was that the digital systems were incorporated. Secondly, the SMS services were incorporated in that second generation phone. However, the switching systems was only circuit switching systems, and those systems were able to carry the data rate of up to 236.8 kbps. In third generation telephones, the technology was digital. Of course, we had SMS services. In that case, the data switching was shifted to packet switching, and the voice switching was traditional circuit switching. And through packet switching, we were able to achieve relatively high data rates, which are of the order of 384 kbps. And then the fourth generation wireless phone, the entire network was shifted to a packet switching network. Both voice and data switching was shifted to packet switching, and overall data rates were relatively higher as compared to the third generation phones. So this was an overall an overview regarding the wireless networks and different technologies that has been used related to different generations of the wireless networks. So we would stop our discussion here, although there are a lot more details related to wireless network, but for the purpose of this course, we have only discussed an overview of different types of network and what are the limitations and capabilities that we generally face when we deploy a type of wireless network in certain environment. So this will conclude the topic as well as the course for the entire semester, because this one is our last lecture. So we would stop here. Thank you all for being with us, being with me for the entire semester. Thank you.